To calculate if something was an outlier.
An outlier is like a really big number that sets off like our entire.
Good. So first there's kind of this so it's a really big number or a really small number that you feel like is messing up your data and doesn't belong. But if you feel like there's a valid reason that it doesn't belong, it just seems ridiculous. Okay, it's way different than the other numbers. And there's two ways to look at it. One, there's like your intuition, right, and your feelings about the statistics, and you see that this number is changing your data. The other way to look at it is that they did come up with a calculation to determine if something is an outlier, right? Now, the calculation is arbitrary, but we want to know what it is. If somebody asks you if something is an outlier, you would either have to say yes with your own justification, or you could show this calculation to show that it's an outlier. So what was the way that we calculated if something was an outlier, even though it's a little bit arbitrary? Okay, so first way to check and see if it's actually really small would be to take the first quartile mark and subtract from it the inner quartile range 1.5 times. So you're basically going to that first quartile mark and seeing if there's stuff that is more than 1.5 times that inner quartile range distance below it, then that stuff kind of seems a little bit far away from the first quartile and maybe doesn't need to be included in our data. Same thing from the third quartile. From that mark, you would want to check if something's so far away from it in the other direction, like large was, that it was too large. So that was quartile 3 plus 1.5 times the IQR. So you wrote this down yesterday. I just wanted to remind you because it's going to answer, again, the next couple of questions we talked about.
So the one that's adding it is for larger numbers? And
yeah.
Subtractions for smaller?
Yeah. So remember that your box and whisker plot looks like this, right? And so what this one is doing right here. Okay, so this is our box and whisker plot. Okay, this is our quartile 1 mark. And this is how big our inner quartile range is. We're basically saying if something is this much and half of this, so like, okay, 1.5 of those beyond quartile 1 this way, it's probably too small for us to include in our data. And then the same idea from the third quartile. So from the third quartile, we're testing if something is too far that way, so that's why we're adding it onto it. So the first quartile, we're seeing if it's too small, and then the third quartile if it's too big. Okay? All right. So what 3 values are needed? Need to already be calculated for us to determine if something is an outlier. So we just talked about how we would do a calculation to see if something's an outlier. And so this question is, what 3 numbers do you need to have picked out from your data in order to do that calculation? So what do you need to determine if something is an outlier? So you have to at least have quartile 1 and quartile 3, right? And then I guess you could really say 2 values. Those 2 values are probably enough. But with those 2 values, you also have to have calculated the IQR from them, right? So you have to know what this point is, and you got to know what the IQR is to see how far away from it you are, right? And if you're too far. And again, if something's like right on the border and you're like, I think this data is not too far and it should be included, but technically it's an outlier, include it, but then state why, because again, it's a little bit arbitrary. They just tried to set some boundary that was pretty like objective, but really this is a more subjective type of thing. So you have to know first quartile, third quartile, and your inner quartile. All right, so we're going to look at, I'll move it down a little bit so you guys can see it better, and then we'll move it back up. So this is the same data we used before. So yesterday, remember, we took some data. You guys found the mean, median, mode. Then we took that data again, and we found like all the different quartiles and created a box and whisker plot. So you guys did all of that yesterday with the same set of data. Okay, we called it example 1 and example 2, but it was all about the same set of data. So example 3 is going to use the same data again and determine if there are any outliers in the data. Okay? So look back at what you did in example 2. Because in example 1, you took the data, but all you found was the mean, the median, and the mode. So you're really going to have to look back at example 2 and look at like the Q1, the Q3, and stuff like that. So let's go back to your example 1. And what did you find as the first quartile? What was Q1? Or example 2, sorry, where you had the 5-number summary of this data. We could line it all up and do it again, but you guys already did it. What was our quartile 1? 8. Okay, and our quartile 3? 21.5. Okay, good. And then that made our IQR equal to 13.5, which was those two things subtracted, right? So basically, if I wanted to look at it mathematically and use this kind of guideline that they've given as an outlier, what I'm going to do is find out, like, what would be the lower boundary for the outlier and see if any of my data is below it. What would be the upper boundary for the outlier and see if any of my data is above it. So remember, to do this, this is the calculation for the outlier where it said to do Q1 minus 1.5 times the IQR. Okay. So what we're going to do right now is we have the Q1 and the IQR value. So we're going to use 8 for Q1 and 13.5 for the IQR, and we're going to do this calculation. Okay. So the calculation we're doing right now is 8 minus 1.5 times 13.5. And what do you guys get when you do that calculation? So do it real quick on a calculator. Multiply 13.5 times 1.5, subtract that from 8. See what you guys get. It's negative 12.25. You guys might be like, that doesn't make sense. Like, we don't have any negative data. We don't have any negative data. But from where 8 was, if you go 13.5 and then half of that, you're obviously going to go past 0 into the negative realm. So if we really are only collecting positive number data, this basically means there would be no outliers on the minimum side of it based on our data set, right? If it was something where you were collecting data and it went into the negatives, okay, then you just wouldn't want to go past negative 12.125. Everything up until that point doesn't seem like an outlier, and then the stuff past that point would seem like an outlier. So the upper bound, we're going to do the same thing, but we're going to take quartile 3 and add 1.5 times the IQR. So for us, this is 21.5 plus 1.5 times 13.5. And what do we get as that upper boundary? 41.75? That's okay. I was like, what? All right, so that's our upper boundary. So anything above 41.75 we would think of as possibly being an outlier. Okay. So in our data, are there any outliers? So basically it would mean, is there any numbers below negative 12.25? Then are there any numbers above 41.75? Yeah. Okay, so if we use this calculation, we would say, yes, there's an outlier. The piece of data that says 45 seems drastically bigger than the others. And do you guys remember when we drew the box plot? It was like everything was kind of close together, all of our little 25% sections. But then that last whisker was like really long out to the 45 because we thought maybe that 45 was skewing our data. Okay? And when you order the numbers, the number right before 45 is 25, and those pieces of data are 20 units apart, whereas all the other pieces of data, the next ones, the farthest apart they are, 25 and 18, is 7 units. So the fact that all the other pieces of data are 7 units or less apart, and then you get to 25 and then you make this big jump to 45, the fact that those are 20 units apart, that could have been a red flag for you at the beginning. Okay, so you could have saw that at the beginning and said this data piece is just really different than how the other ones are related to each other, or you could do this exact calculation and figure it out. Okay. All right, so you guys calculated the mean and the median already in example 1. Okay, so look back at example 1. What was our median of the data set? 12. Okay, and what was our mean or our average of the data? 15.8 repeated. All right, so now let's do those same calculations without the outlier. So basically what you're going to do is you're basically going to remove 45 from the data set because we've determined that we think that it's skewing our data, that it's not really representative of what's happening. It's one kind of strange case, right? And now we're going to look at the numbers that we get if we don't include that data. So take 45 out of the data set, use the remaining numbers, and find what the mean and median are now. Okay? All right, what did you guys get? What did we get? 12.25 for me. Okay, and median? 10.5? All right. Good job. All right, so the idea here is, what do we notice or what's happening? So notice that our median moved down a little bit because we took off one giant piece of data. Okay. And then our mean is closer to what our median was before. Okay. So we want to make some decisions about if this is a better representation of what's going on. Okay, so we're going to do a couple more comparisons. Okay. Is everybody okay with this? So basically how you would determine if something's an outlier, if you want to use kind of an objective way, you can use this 1.5 times the IQR added or subtracted to create a boundary for yourself. But you also have to be a critical thinker. You can't just like rely on that. You have to think about if it seems like it belongs or not. All right. We are going to do, we're going to do the same thing that we did before. Okay, so this one set of data is doing all of our examples. So first we found the mean, median, mode of all the data. Then we went and found this 5-number summary that they call it and created a box and whisker plot with all of the data, including 45. Then we knew when we drew it that the one whisker seemed really long, and we determined that possibly 45 was causing that. We talked about what an outlier was then to determine that sometimes there's a piece of data that is making our data set seem different than what it really is. Then we just talked about how you could have an objective way to determine if something is an outlier or not. And if it is an outlier, you can kind of kick it out of your data set, and then you can calculate the numbers without the data. So we're going to create a box and whisker plot with the same data we did before, but again with the 45 removed this time. Okay? So our outlier is 45. That's the only place we're going to list it, and we're not going to include it in our list of numbers. Okay? So our minimum, what's the minimum from that data? So you guys wrote down the data from the last problem or from example 2. So the minimum is still 4. What's our maximum? If we're calling 45 our outlier, where are we now stopping our maximum piece of data? 25. All right, now this means the range of the data. Remember, the range is the maximum minus the minimum. So it's going to be 21. Yes?
Do you always exclude your outlier from all of this information?
Yeah. So the point is, and maybe you have to do it twice to figure it out. So this is where statistics is a little bit more like you really have to be able to explain yourself and what's going on. Because maybe you think the number's okay when you just look at the numbers. Then you look at the graphical representation, and you're like, everything seems good but this one part. Then you go back and look at the numbers and figure out there was one really low number or one really high number that was throwing everything off. Okay? And so then what you do is you exclude the outlier, but you exclude it from your calculations, but notice it's still included right here. So we're still going to represent it. We're just not going to let it influence all of our numbers. Okay? All right, so you guys just found the median of these with 45 removed. What was our median? It was 10.5. Is that right? You guys just told me, but I changed the screen. Thank you. All right, so now we need to find the lower quartile and the upper quartile, or quartile 1 and quartile 3. So again, you want to order your data and find those this time without the 45. So our data, 4 was our minimum, then it was like 7, 9, 9, am I right? Will you guys look at your list and tell me? And then 12, 14, thank you. 25.
So do you just put the first 4 and the second 4 in for the lower and upper?
Yes. So our median became 10.5 because these two numbers were in the middle together. So we created the median here as 10.5, which means, yes, these 4 numbers are still our lower half of our data, and these 4 numbers are our upper half of our data. Okay? So our quartile 1 is going to be the average of these 2 numbers, 7 and 9, which would be 8. Interesting how that didn't change, okay? But that has to do with the fact that we just threw out one piece of data. Our median still these 4 in the lower half of the data. And then our third quartile is now going to be the average between 14 and 18, okay? So the number that's directly in the middle of 14 and 18, or if you add them up and divide them by 2, you get 16. Okay? Uh-huh. So if this is the lower half of my data, right, these 4 numbers, and when I'm finding a median or a quartile, I'm trying to find what's in the middle of that half. So of these 4 numbers, there is no direct middle. The middle is going to be somewhere in here. So I have to take these 2 numbers surrounding where the middle would be, and I average them. So 9 plus 7 is 16 divided by 2 is 8. Okay? And then here, there's 4 numbers again, right, which means the middle would be right here, but there's no piece of data right there. So I take these 2, I add them up, divide them by 2, and I get 16. The only one you don't include in that is the median. So if the median was an actual piece of data, it wouldn't be included in the lower half or the upper half because it is the middle. And when it's not a piece of data, we average the 9 and the 12 to get the 10.5. That's still the division line, but now the 9 is part of the lower half and the 12 is part of the upper half. Okay? All right, so the IQR here, just like the range, we subtract the Q3 and Q1. So 16 minus 8 is going to be 8. All right, now we're going to make the box and whisker plot again, so this will review and make sure you can set this up the same way that you did yesterday. Now you might think, oh, cool, now I only have to go up to 25, so I can number my axis a lot less. Not true. So remember how we said we're throwing the outlier out, but we still want to represent it? We still have to make a mark to show somebody there was a piece of data there. If you never mentioned it to anybody, like you just threw it out and just like never told anybody that piece of data existed, you would be considered to be like deceptive by doing that. You want to be straightforward with people, so you might give them all the stuff you want, but you have to somehow show them that there was this number that was out there, but you chose to exclude it from the data to give a more accurate picture. So I'm still going to number by 5s like I did last time, because I still need to reach from 4 all the way to 45, even though it's an outlier. So I don't know, 0, 5, 10. Okay. So just how we created a box and whisker plot, we normally take our minimum. It creates a point at 4. Our quartile 1 is at 8. That's going to be the beginning of our box, so I'm just going to make a mark like that. Our median is at 10.5, so really close together. Our quartile 3 is at 16, and then the maximum is at 25. So now our box and whisker plot looks like this. Okay? A little less extreme than it looked before. Okay? Before, this was stretched out a little bit more, but then this last whisker stretched really far away. So it seems more like representative of 25%, 25%, 25%. I still look right here and think, wow, like this 25% of the data, there's a lot of stuff happening close together. Like a lot of people are doing something in a small range of numbers between 8 and 10, basically. Right? Now, how I marked that there was an outlier at 45, I put a point at 45 with a little X. So I just marked like, yeah, that's that piece of data that I chose to exclude. So this way I'm not being misleading. I'm giving people this new representation that I feel is better, but they know that there was something else out here that I excluded from the data when I did the calculations to get that. Okay? So that's how we represent it visually. All right, are we good with all this stuff? We get how to make the box and whisker plot and all this language about IQR and quartiles. Okay, we'll come back to the practice part. You guys are going to do that. All right. So the big deal once you make one of these, and this is the big deal with all of our graphical representation, and I think that, was it this class at the end yesterday? Somebody was asking me about like, oh, is this stuff going to be easy? Because it seems really easy. I think it was third period. And I said, the calculation part of it might not be that hard. and the graphs might be familiar, but the thing about statistics, it's not like you can memorize one thing and then be good. You have to memorize the one thing to do the calculation, but then you have to be able to convey to somebody, oh, I did this calculation, it came out like this, and here's what it means to me. Like, here's the information that it's giving me. Like, how we looked at that, like, is student the most dangerous occupation, right? They tried to make us think that. They were kind of lying to us, right? But you have to be able to take that information and interpret it and give it meaning and conclusion, because that's usually what you're doing when you're collecting data, right? You're trying to draw some conclusion of if something is statistically better than other options, and that way you can advertise and say things like, oh, significantly more people got better when they took this medicine compared to this medicine, or whatever the case may be. Okay? All right, so what percent, so this is the box and whisker plot, okay? We talked about this when we had people up here, that no matter how stretched out it looks in certain areas, 25% of the data is in each portion. Okay? Even if a portion looks larger than something else. If it's a small portion, that just means maybe the data was like 18, 20, like stuff that was really close together for that 25%. And the stretched out portion still has the same amount of data, but maybe it's like 25, 27, 31, so the data spanned a larger space. Okay? So what percent of the data falls between the minimum and the lower quartile? 25%. Okay? Oh, really? Okay. What percent of the data falls between the lower quartile and the upper quartile? So quartile 1 and quartile 3, how much of the data is in that area? 50%. Okay? It's 2 of the 25% sections. What percent of the data falls between the minimum and the median? 50%. Because remember, your median is your middle marker of your data. So half the data is on one side and half the data is on the other side. Now, you might look at this and say, no, Ms. Dahl, look, the median is a lot closer to the minimum than it is to the maximum. That's fine. There still might be 5 data points on that side of the median and 5 data points on that side. It's just that the 5 data pieces over here, their numbers are closer to being the same number as the median, and the 5 data pieces over here might be really spread out, like how we looked at bedtimes, right? Okay, our median was pretty close to the minimum. They were only like an hour apart, but our median and our maximum are like 2.5 hours apart or something like that. Okay? It didn't change that there was still the same amount of pieces of data on each side. Okay, what percent of the data falls between the median and the maximum then? The median and the maximum. 50 again, right? Because the median is exactly the middle. So if it's median to minimum or median to maximum, then it's 50% on each side. Right? What percent of the data falls between the lower quartile and the maximum, or quartile 1 and the maximum? 75%. Okay, so this is just trying to drive home that idea. And again, it's because of exactly what I'm telling you. People look at this and they say, oh, look at that, that's bigger. There's more data in here than there is in here because it's bigger. Okay? But that's not true. There's just as many data points. They're just more spread out on that side of the median than they are on the other side of the median. Okay? And that might be important to you because you might think, oh, this is the middle. But you know what? The 50% on this side, that's where most, like, they were closer together. So I bet that more people are, sleeping at this time or something like that, whatever it is that you're looking at. All right. Okay, so here's a box and whisker plot, and we're going to see which conclusion must be true. Okay? So they show you this, and you're supposed to be able to infer some information about it. So here's our 4 choices. The median age is 24. The lower quartile age is 18. Half of the ages are between 23 and 30. The inner quartile range is half of the range. All right, so somebody eliminate one for me. Something you see that's not true. Jordan. Okay, so why is C not true? Good. So she's saying from 23 to 30 is more than half the ages, not because of anything to do with these numbers, but because to do with the fact with the marks that we see right here, this is 25%, 25%, and another 25%. So that captures 75% of the people, not 50% of the people. So this is not true. All right, and then, Ariana, you said another one. What did you say? A. Okay, so how does she know the median age is not 24? Yeah. Okay, basically if we understand the markings, right, this is our median, and our median is occurring at 25. Okay. All right, lower quartile range is 18. The inner quartile range is half of the range. So B is false. Okay. So the lower quartile is happening at 23. All right, which means D must be true, and we could check that if we wanted. The inner quartile ranges from 23 to 29. So 29 minus 23 would give us 6. Okay, so this is 6. And the range of the problem completely is from 18 to 30. 30 minus 18 would be 12. So is it true that 6 is half of 12? Yeah, that works. Okay. Again, why would this be important? It's interesting for you to know the center of the data, like how I said with test scores, how I want to know what the median test score is so I can understand how far away people were from the middle score of the test if I lined them all up. And also the spread of the data. Okay? If I looked at your test scores and the median was right here and all the upper ones were really close to it, but then the lower ones were really spread out really far, what would that would tell me is that this is the middle score, but it's also like most people scored really consistently close to the same score in this area because the data is all close together. Whereas where it's like spread out really long to take up that 25%, that tells me like there's a lot of different scores spreading stuff out, or one score maybe spreading it out really low like the outlier. Okay? All right, we'll come back to this. All right. So this is a double box and whisker plot. Okay? So the purpose of having a double box and whisker plot would be, what if you don't just want to make conclusions about one thing, but you want to compare two things together to see? So like oftentimes as a teacher, I would do this. Either I would just ignore the fact that I have separate classes, and I would clump all my periods together to look at the data. Okay? Or what I would do is, because sometimes I'll see, like, gosh, I feel like this class takes longer to learn something than my other class. And then what I can go through, if I feel like that's a consistent feeling, is I can go look at some data and see if I feel like there are students who generally score lower in that class, then what I could do is exactly what's happening here. I could compare maybe a test score or a quiz score or something like that from my first period to my third period or something like that, and see if I see a difference in how students score. Or is it just that during that period we take longer, but in general their scores are the same and it's really not that big of a deal? And then that could help me kind of solve the problem. Like, is it instruction or is it like student knowledge? Yeah. But we're going to finish talking about this first. Okay. So the double box and whisker plot compares the two things together so I can see where the spread of the data stands and how, like, is one class doing better or not. Okay. So you're going to look at these two box and whisker plots, okay? And I want you to see in your groups if you can come up with at least 4 things, 4 kind of conclusions that you can make about your class compared to your friend's class. And obviously this is hypothetical because these were already made. And I didn't make them based on any scores comparing you to another period. These were just given. But so what I want you to do in your groups, okay, again, is try to look at these and see if you can draw at least 4 conclusions that compare something about your class, the blue box and whisker plot, compared to your friend's class, the red box and whisker plot. Okay? So see if you... All right, conclusions. Taylor.
Our class overall tested better.
Good. Your class overall tested better.
And
Jordan.
overall, your class has, besides just having higher scores, there are more people scored higher. There's less of a
Range. Good. Okay. So you guys have both pointed out the main things we like to look at data. When people talk about data, they say we like to measure the center of the data and the spread of the data. So in Taylor saying that our class scored generally higher than the other class, we're kind of looking at some sort of center measurement, right? that the center for here was over here, and the center here was at a lower place. Okay? And then what Jordan pointed out is the spread of the data. Okay? Not only did our class score higher, okay, but look at the, like, especially 75% of the scores are basically at 85 or above, right? Whereas in the other class, that same marking goes all the way down to 70. There's 75% of their scores. To get those, I would have to go all the way down to 70. So yeah, the range would be much less. So I would definitely wonder, this would make me as a teacher want to go back and like look at these students, like past math experiences and stuff like that, or do I have students like not trying in this one class versus the other? Sometimes I throw them out as outliers because I don't want to like skew my data, right? And I want to look at people that are trying and the scores that they're getting. If I know they're not trying at all and they're getting like one question right, I don't really want to include that in like how great my class is doing because I already know that's a special situation and something going on there is not right. Okay? But I would definitely want to go back and look at what's going on in this class that's in red. Why are they significantly lower? And I would feel like they were significantly lower because look at how far spread out the inner quartile range is in the blue compared to the red. It's much more condensed, which tells me a lot more of my scores are happening next to this middle score. This middle score is nice and high, okay? And so that would be, I'd be like, yay, okay, check the box. And with the red class, I'd be like, okay, it's not bad to have a median of 80, right? This is probably a more classic spread for a class, right? But if these were two of the exact same classes, I would definitely want to look closer at what was going on there. Okay? Anybody else notice anything else they wanted to add? All right, but good job you guys paying attention to the center of the data and then how much the data is spread out, because those things are both really important. All right, so what we are going to do, and you're not going to collect data from here, you're going to use the data we have. So your job, just in time, right? Okay, your job, your homework, okay? There were practice makes perfect little things throughout this handout. You need to complete those. The handout's on Canvas if you don't have it. Okay. Then at the end, there's this thing that tells you to create a double box and whisker plot. So two separate box and whisker plots just put on the same graph. One about female height and one about male height. I'm not going to have you walk around and collect data because we already have this data. Okay. It is shared with you in your Google Drive as the responses to the survey. Don't go back and take the survey again. Use the email that had my full name. It said like Melissa Dahl, and it said survey responses, an item has been shared with you. If you click on that, you'll see now that we have like 53 responses or something like that, so plenty of data. I want you to take all the females and clump them together. Write down those heights in inches in order, okay? And make a box and whisker plot for female height. Then do the same thing for the males, makes the box and whisker plot for them, and put them on the same thing like you just saw those two box and whisker plots together.
Something like height, would there be like an outlier there really? Unless someone's like this.
There, yeah, like, so I don't feel, like, I'm guessing there's probably not going to be an outlier for height, okay? But we didn't see any outliers in the ones we just looked at, too. But in the data we looked at earlier, we definitely did. But that's going to be a calculation you guys are going to have to do and see, right? Because it's going to depend on our class, unless there was somebody drastically tall that probably not. Does everybody understand what their homework is? So there's a couple things throughout this packet you have to do, and then in addition to that, you have to do this double height box and whisker plot, and I'm stamping it tomorrow. Okay? Everybody understands. You know where to get the data. Yes? Okay? In your Google Drive was shared with you to a survey everybody filled out. Yes?